Hey guys, you are listening to the CoinMonks podcast, a place where you can learn new things about the crypto space directly from the leaders and founders in the space. This podcast is our latest offering alongside our long running Medium publication that offers tons of educational content on different crypto products and other trading related products. This is your host Akash, and on our very first episode today, we have Dmitry Shklovsky, the co-founder at Quicknode. At Quicknode, they're building blockchain infrastructure as a service for the future of the Web3 world. Let's hear more from Dmitry himself. Hi, Dmitry. Nice to meet you. How are you doing today? Welcome to the CoinMonks podcast.
Hi, Akash. Pleasure to be here. I'm doing well, thanks.
Just to get the ball rolling, why don't we start with the quick introduction on you for our audience and a little bit of a background on what you do?
Sure. My name is Dmitry, co-founder at Quicknode. For the last about 20 years, me and my team have been working building data centers, managing thousands of servers across various different stacks, building distributed networks all around the world. And around 2017, we decided, what do we do next? We had just finished the acquisition of one of our companies, which was a content delivery network. What's next for us? How do we apply our experience in building Web2 technologies? And we'll get into Web2 and Web3 later, but for the purpose of the explanation is helping build sites like YouTube and Facebook and those kind of technologies, the web that we're using today, and how to build the next iteration. And so we saw some of that happen in 2017 with the introduction of the Ethereum blockchain and smart contracts, and that was very fascinating for us. Mm-hmm. This is where we can apply our experience, and we can get into why we decided a little later, but just to, for the purposes of background, we've been in the IT and infrastructure space for a long time, and this is a topic and technologies we're very familiar with, and we're super passionate to be able to bring that experience and expertise into this next iteration of the internet.
Right, awesome. That was a really nice introduction. I'd say when you mentioned CDNs, is that the technology behind servers that are used to transmit videos and data faster for services like YouTube and Netflix? Is that what?
Oh yeah, absolutely. Thanks for explaining that. Yeah, basically, traditional web hosting is you have your data living in one place, in one location. Any person around the world has to connect to this location, and what that happens is, if let's say your website is hosted in New York and you have someone from, let's say, the Netherlands accessing it, they have to go through several networks across the Atlantic to access that information in New York. What a CDN does is it takes a copy of your website or your video, your sound, music, whatever, and it creates copies of it all over the world. So, when somebody accesses it from the Netherlands, it is going to be routed to a data center. And the data center is just these big rooms that have thousands upon thousands of servers in them, with really, really high speed connections and redundant power. Basically, this is the core of the internet. So the core of the internet lives in a bunch of these data centers around the world. And what happens is that data is then served from the nearest, and what that does is reduces latency. And latency is the time it takes for the server on the other side, from the moment you click play, let's say YouTube, to the moment that video begins playing on your computer. There's a little bit of a delay. And I'm sure you've all had times where the YouTube loading icon is just spinning for a while. And that's probably because maybe a copy of that video doesn't exist anywhere nearby. So it's happening from the next nearby station. But the purpose of a CDN is to bring the content and data as close to the user as possible to provide a better user experience. When you click play on YouTube, you want it to play right now, not in 10 seconds. You want it to play right now.
Yep. So yeah, the reason why I guess I asked about that is because that sounds awfully lot similar to a network of boxes or nodes that we have in the decentralized web system as well. Especially with blockchains, you have nodes that are very similar to a CDN box streaming transactions and things like that. So yeah, that sets up a nice segue as to why space. But talking a little bit specific about infrastructure and tooling and the problems that are in that ecosystem, why did you decide to specially tackle the problem of Ethereum nodes as a service?
Absolutely, great question. So Quicknode does more than Ethereum. We started with Ethereum, but at the moment we support 9 different chains. We're introducing a 10th one in a couple of weeks. So it's the future is multi-chain, and we can get into that later. Why? Because we have seen and participated in the transition from Web 1, which was just read only. You would go to a website and maybe read a newspaper or like look at an image, but you couldn't really upload anything, or you couldn't modify time. We saw and we saw the transition and helped, in some open source technologies, and contributed to them, create the Web 2, which is the current iteration of the internet, which is things like Facebook, where upload images and you can transfer things, and you can share content. And we saw a little bit of that happen, like I mentioned, in 2017. We saw this new layer. It's powered by blockchain technology, but smart contracts takes it a level further, in the sense that cryptocurrency is one application of blockchain, and it's the most prominent and widely used application. So now you can trade money. There's a money layer on the internet, a trustless, decentralized money layer on the internet, and it's different from sending money through banks or PayPal, where you're relying on third-party trusted sources.
Right.
And if you've ever sent a wire, especially internationally, sometimes the money is just in this like limbo state where it leaves your account and it doesn't hit the recipient's account. It's just somewhere. And there's numerous ways that the third parties make money off of that. But now there's this trustless, decentralized layer that's nearly instant, depending on which blockchain you use. And we saw with the smart contracts take that a level further, because now you can program not only money, but now we can get into NFTs and DAOs and things like that a little later. But now you have this completely additional layer to the internet, which enables things and revolutionizes industries that just was not possible before. And we can get into use cases like insurance and medical records, and real estate transactions and identity, and things like
Right.
that.
So okay. So like from what I understand, you basically saying that Web 1 was all about reading, Web 2 was both read and write to the internet,
Mhm.
and now you have Web 3 where you can read, write, and also verify things, if that makes sense. So
Absolutely.
yeah, so let's back up a little bit. So Quicknode is a service that allows developers to get access to a Ethereum node virtually without running one on their own end, from what I understand, right? So what would be a Web 2 equivalent of a service like Quicknode? So I was reading about you before this podcast a little bit, and I came across an article by TechCrunch, and they mentioned that Quicknode is a developer cloud platform that will be competing with AWS. So, what is a service that exists in the current internet that is comparable to what Quicknote does?
Sure. If you think of the blockchain, it's a ledger. It's a long running list of who owns what and what is the state of something, or what is the state of this ledger, which changes every, in Ethereum's case, it changes every 12 seconds.
Right.
In some of the other chains like Polygon and Phantom, they are a couple of seconds.
Mm-hmm.
In Solana, it's also a couple of seconds. So the state of the blockchain changes every couple of seconds, and so it's just a database. And so I'd say majority of the applications we use today are powered by some sort of database in the background, whether it's MongoDB or MySQL. Yeah, just to name a few. And there's many companies like Amazon, Azure, that offer managed database services, but those databases are usually proprietary. They're unique to that particular company, and that company controls every aspect of it. There's no decentralized, trustless database, but now there is in the form of public blockchains. And so we maintain the nodes, which are pieces of software which connect to other nodes on the network, and then they reach consensus on what is the truth, and this connects with the mining process, and that's something we can get into later. But it essentially keeps this and historical states of the blockchain, of that network. So if you wanted to access either the latest data on the blockchain, or you wanted to access historical data on the blockchain, you can do that by making a call against a Quicknode URL or a Quicknode APL. So we are essentially like a managed database service with a platform on top, which gives you more than just access, but also security, analytics, higher level abstractions. Obviously, the whole goal is to make it as easy as possible for users to build decentralized applications, to power their decentralized applications, and give them powerful features to help them build the best version of those applications.
Right. So let me know if I got this correctly. The current version of the internet runs as a network of servers that are controlled by different parties, but there are, inlets and outlets that connect to other things, and that's how the network works. So for blockchain, we have a parallel to those servers. You could say we have these nodes. So for example, with Ethereum, you have Ethereum nodes that do the job of a server, and they have all the state data of the chain, and they're sending out all the messages and things like that. So you're essentially creating these servers on your end and leasing them out virtually to other people to use them to query the data that's on the blockchain. Is that what it is?
Yes, that's on the surface. Yes. So if you wanted to, just like in the Web2 days, if you wanted to host a website, you would have to run a web server, maybe on your home computer, or you would rent a server in a data center, or now you have cloud server options. But you would need to run a web server like Apache or Nginx. In cases, you'd also need to run a database server. But here, the backend, the database, and many times now with IPFS, your front end stuff can be hosted on this decentralized network of nodes. And yes, we completely abstract that layer, that infrastructure layer, and just simply give you a URL which you plug into your code, and that basically powers your application.
Got it. So, okay, so let me ask you on this. So, for example, if I'm a DApp developer, right, do I necessarily have this in order for me to be able to run a DApp application company? So, like, what I'm trying to ask is that if I'm a smart contract developer and I put my smart contract out there through a transaction in a block, say a smart contract for a product like Uniswap, will I have to necessarily use a Ethereum node on my end, or use something like a Quicknode in order for me to be able to run my company? Because from what I understand, if the code is already on the blockchain, the the product will work. The only thing you will need an Ethereum node, if you want to have it on your own end, is to analyze the inputs and outputs to that code and the user behavior around it. But the core application can run without you ever having to host your own Ethereum node or a quick node.
Correct, and that's the beauty of smart contracts and blockchain, is you can and it's in the blockchain, it's there forever, and it'll run exactly how you programmed it. But here's where Quicknode comes in. So you will likely use some kind of wallet software that will submit your transaction to the network, because you have to submit a transaction to the network, you have to node. So this wallet application has to be connected to the blockchain somehow, and that's where they will, like the wallet application will need to use something like a Quicknode, but that's transparent to you as a developer. There's a handful of common wallet or user interface programs, but on their back end, they're using a Quicknode. But here's application of Quicknode where it comes in is, let's say you have a front end for your application, somewhere where you want to surface analytics or data, like you mentioned, about your particular smart, who's the biggest holder of the tokens of the smart contract, or who has interacted with your contract the most times. That you will need to pull data from the blockchain, and if the state changes every 12 seconds, you will have to poll the blockchain every time there's a new block created to get that data. And you also mentioned Uniswap. So Uniswap is a front end, but that front end is powered by something that's connected to the blockchain. And every time there's a new block, the state of a bunch of smart contracts are changed. And so what you see when you load Uniswap is, well, every time you load a website like Uniswap, it's getting this data in real time from the blockchain. And behind that are networks of nodes. And where Quicknode comes in handy is when you have maybe users, okay, one node is fine. But when you have hundreds of users trying to use your application at the same time, you'll need a much more robust, much more complex setup. And that's the problem that Quicknode solves for these businesses and projects that are in hyperscale mode. Some of these projects are onboarding 10,000 new users per day, and a single node is not going to handle that. And these users are also coming from all over the world. So if you have your one node in one location, it's going to be very, very slow for someone who's on the other side of the world. So there's these additional abstractions and these additional pain points that Quicknode solves, auto scaling, like being multi-cloud, and having this global presence that basically make it easier for you to run your dApp,
Right.
and give your user a much more pleasant experience.
Right. So I have actually a very specific question on that. So when you say that as a DApp service, you would ideally want a big network of global nodes so that if you have a big user base, they can easily push out their transactions, which is essentially the way in which they will interact with your DApp. So if some DApp company is running quick nodes, a quick node that, so from what I understand, Ethereum nodes are public nodes and they're agnostic to what kind of transactions are coming in. So, for example, if somebody was submitting transactions for 1inch versus Uniswap versus Curve to a public node, it'll take all those transactions in and put them in a block depending on the gas situation. But if you're using a quick node, can you create a node that specifically processes and pushes transaction particularly for a particular DApp? Is that something that Quicknode offers?
Okay, if I understand the question correctly, I'll try to explain the process of getting a transaction into a block. So first, you submit a transaction through an Ethereum node, and then that Ethereum node will then propagate it to all its peers, and those peers will propagate it to all of its peers, and eventually it ends up in a place called the mempool, which is kind of like the staging area for all transactions. And from that mempool, miners, which are those that process these complex mathematical equations to come up with the source of truth and enter a transaction into a block, they decide on which transaction to mine depending on the gas price. And gas price is the fee that a user pays to change the state of whatever they want to change on the blockchain. So with Quicknode, I mean, generally, if you're running a single node in one location, you submit your transaction to that one node. And if that one node only has 50 peers or 100 peers, it's only able to reach those 50 to 100 peers in that moment. But with Quicknode, since we thousands of nodes all around the world across different clouds, every time you submit your transaction to any of Quicknode's nodes, that automatically gets propagated network. And so the discovery of your transaction is a lot quicker by other nodes, by miners, and thus you also get a much wider visibility of the network if you're reading transactions. But as
I
far
see.
as application specific, there is no application specific, because whether you're sending a transaction or interacting with a smart contract, as long as you're paying the gas and you incentivize the miners to take your transaction, process it, the way that we help is just helping propagate your transaction to all the other nodes across the network. Can then say, hey, I'm going to process, I'm going to take this fee.
I see. So let me know if I got this right. I think I got it. So basically, what you're saying is that Quicknode acts like any other public node, with the difference being that because you guys are so present in so many geographies and have such a robust network between your own nodes, that the speed at which the transaction gets propagated across a bunch of peers is much faster compared to some of the other public nodes.
Absolutely, absolutely. And if you've been listening from the beginning, this is the experience we're bringing over from our running a CDN network. Because when we were building that CDN network, we've read a bunch of studies, and this was when CDN was still a new technology, and companies like Yahoo and Amazon and AOL were investing millions of dollars into research, and they came up with, and you can Google this and you can read this, but something like if the website loaded a second faster, the user was 80 times more likely to purchase something, or click on a call to action, or return to the website after closing it. So speed is directly connected to our psychiatry, our psychology rather, and gives us pleasure. When something happens instantly and happens on demand, you get a good feeling, and we're trying to bring that kind of, because blockchain is notorious for being slow. At least now, there's new iterations of smart contract blockchains which are much quicker, but still, there's still that latency and that speed that we're trying to bring and make it as close to a Web2 experience, but now with this decentralized, trustless layer.
Got it. So, so let me go back to something you mentioned a little while ago. You mentioned that Quicknode, because you're running essentially public Ethereum nodes, you're getting in and out a lot of data. In fact, all of the data regarding the state of the blockchain. So, what that gives you is a position where people can essentially use your nodes to run analytics on the blockchain, right? So, how does your service compare to some of the other infrastructure projects that offer something similar when it comes to like data indexing and data querying for blockchain data? I'm talking like specifically with respect to like the graph or the covalent, and these are decentralized networks. They have their own token. So, I mean, how does that compare to what Quicknode offers in terms of analytics?
Sure. And look, we're all for we're all for decentralization, and we're trying to make our product as distributed, decentralized as possible. Not relying on any single cloud provider, not relying on any single region, to try to make it as redundant and as robust as possible. Behind every subgraph, you still need to get data from a blockchain, and that requires connecting to a node, such as a Quicknode. And so we have a lot of customers that use Quicknode for indexing, creating their subgraphs. So behind every subgraph, there's still a need for something like Quicknode. And then if you think about, there's different use cases. So some businesses are fine with the way that subgraph works, or the graph, and they create their own. Others need more robust solutions. So whether with regards to speed or with regards to availability of the data, and for that, having a company like Quicknode, which can offer you a service level agreement, an SLA, an uptime guarantee and have live customer support. For them, that's important. There's just different applications, and I think there's a place in the space for all of it. It's nice to have options. So if you some customers run the graph and in parallel they connect directly to a blockchain node. Others prefer just to use subgraphs, or others prefer nodes. So it's just different. It's nice to have the choices. You know, it's like what's better, Amazon or Azure or Google? Ideally, you would use all three, because you don't want to, you don't want to rely on any one to have, to decide the fate of your project, really.
So, I mean, I was thinking that maybe because you guys are running your own, I mean, I'm assuming you guys are running your own hardware for your network. Maybe you would have some other sort of advantages compared to a decentralized protocol where you can serve like custom indexing features or custom analytics to companies. So, is that sort of an advantage a big player could get? Like, basically, let's call it personal attendance to their problems that they might not get from a decentralized network.
Perhaps, we're trying to build a standardized product which suits a wide range of needs. We are always listening to our customers, and sometimes they're making they want to make like 500 concurrent requests for a certain kind of data. So we have built these additional layers, these middle layers that help accelerate that. So if you send 500 concurrent requests, we have a load balancer layer in the middle that's going to send 10 requests to one node, 10 requests to another node, 10 requests to another node. So you're going to get back a lot quicker. This is maybe something you can get with. I don't think you can get that with another provider, but there's definitely these unique middle layers. Like I mentioned, there's the data aggregation layer. There's definitely some indexing going on to much like a CDN and caching. If there's a very popular request, there's no need for that request to go and have the node do calculations on it when it can be served from cache or an index.
Right.
There's also, we offer a mempool aggregation layer. So again, because we have this global network and we have this super wide view of the mempool and all the transactions that happen on it, we aggregate that data into like a central mempool and then serve that to our users. So let's say you're and you're listening to a node in New York and the transaction originates somewhere in Singapore. By the time that transaction propagates through the various nodes and networks and reaches your node in Singapore, your node in New York, it might be a matter of hundreds of milliseconds to several seconds. But since nodes in Singapore and in New York, we will, as soon as any one of our nodes sees that transaction appear in the mempool, we will notify you through your most likely WebSocket subscription. So there are these additional layers that give our users an advantage over using another service or running their own node in-house.
Right. Makes sense. Yeah, I think that clears up the differences, and if I understand correctly, a lot of similarities between the other data indexing query projects in the space. So let's talk a little bit more about the actual customers for your product. So from what I understand, you guys have some very big known names in the industry: Chainalysis, Dune Analytics, Fireblocks on your website. So can you talk a little bit about who the customers are for your company and why they need this?
Sure, absolutely. And again, this is one of the reasons we wake up every day and we try to build the best Web3 infrastructure platform, is because when we see who signs up for our platform and who's actually using these services and seeing, and it's generating a lot of value for them, that just gives us a lot of drive to keep doing this and do it better and do it bigger. So you mentioned analytics. So yes, Dune Analytics, Nansen, these are well-known projects, funded projects, and they're using our services across multiple chains because they're also multi-chain and not just Ethereum. They're not just Polygon, but and provide analytics across a number of networks. And at some point when they were much smaller, they maybe they were running these services in-house, but at a certain point, they realized that if they want to scale and grow bigger and get this data faster, they're going to need basically hire DevOps people and hire customers, support people to monitor this stuff. And if you add all that up, it's a significant expense. Whereas if you were to work with someone like Quicknode, a company which does this day in, day out, this is all they do. This is their bread, this is their main point of focus, day in, day out. A, they would save a lot of money. B, it opens up a lot of time that they would instead be focusing on things like node issues and scaling their infrastructure to focus on their core product instead. So it's all about saving resources. The most important one of that is time. Time is money. So obviously you're saving money off using Quicknode versus doing this in-house. But then we also work with companies like Horizon Games, which is a blockchain gaming company. We work with Zedrun, which is a popular horse betting game that's powered by Polygon. There's this wide variety of use cases for the blockchain, but they all require pulling data or sending data to the blockchain. And to scale to tens of thousands and hundreds of thousands of millions of users, you will need a enterprise grade or a very robust node solution to back that up. Just like if you're running a very popular website, you're not going to run it on one web server. You're probably going to have racks or rows at a certain point of just powerful machines that are crunching numbers, or they're doing their best to serve this content to the end user. So this is where Quick helps solve the node infrastructure or the Web3 data read and write problem for some of these large projects. And now what's interesting is we're seeing public companies, Fortune 500 companies, and for example, Coinbase is a public company as of this year. They find value in what we're building, and we're constantly evolving and making more robust, listening to the customer feedback. We want to support this next. We want to support the economy. We want to support the decentralized autonomous organizations, the new wave of how companies and organizations are going to be built and run. And ultimately the future of finance, because I feel like this is how we are going to progress as a society.
Right. That's actually a lot of great insights, and I think what you're essentially saying is that for any Web3 company that's going to deal in volume, whether it's in gaming, whether it's in trading, at some point, in order for them to have a very robust analytics, the cost of setting up the infrastructure for that will be far too much for just a startup to afford that. And it would be always much better for them to reach out to someone like you who already has that infrastructure in place and can provide them with whatever queries they want.
Right. So just like every company became an internet company, every company will eventually become a blockchain company. Some aspect of their application will need to speak to the blockchain in some sort of way, whether it be authentication or like identification, or it'll verify some information, some kind of credentials. Like if we're going to establish, maybe some companies or some projects will have like a meritocracy. So if you have your university diploma on the blockchain and you can prove that this is your identity and this is your diploma, then you will have the ability to maybe vote on some certain topics or participate in some certain events. Same thing with having things like passports, driver's licenses, and vaccination records. Medical records are super important, but a lot of times they are kept in a silo. To get them, you have to go to that one specific place, and
Yeah.
their security is good, sometimes not so much. There have been data leaks, um, numerous data leaks from some really, really big firms, and also the monetization of this data. So we're uploading all this data to Facebook, Google, Instagram, but on it, it's
Mm-hmm.
Instagram and Facebook and Google are monetizing on it. But what if you could have your medical data, for example? And there was a talk, there was a MIT talk on this, where how can we revolutionize this medical data problem? What if you had access to your data, and through using zero knowledge proofs, which is a way of verifying data without actually revealing this data,
Right.
you're able for a company to advertise to you without them knowing who you are. So let's say you have your medical records, and you have a particular condition, and you want to be advertised to, like with your consent, but the
Mm.
advertiser will pay you directly without your revealing any of your private or personal information, but they will be able to advertise to you and pay you, say, whatever, 50 cents for them to see, to deliver this ad, very relevant ad that you might actually want to see, and become a consumer of this product. So again, this is where we see the space going. I feel like today, sure, cryptocurrency and being able to transfer value around is a very common use case, but we're seeing more and more we're seeing an evolution of that through NFTs, which is digital art, content like writing, books, audio. The Audius project. There's a number of new NFT projects that are working around basically rewarding artists directly, instead
Right.
of working through record labels and
Mm-hmm.
third parties. So yeah, the blockchain and blockchain technology is going to penetrate every single aspect of our lives, and it will be transparent in the same way that in many ways the internet is transparent to the newer generation
Mm-hmm.
of that grew up with the internet, that grew up with Instagram and Facebook. Like, that generation does not know a world without internet, and so the next generation will not know a world without blockchain. And so
Right.
a lot of these things that you do with regards to banking, financing, buying real estate, exchanging any kind of goods or transferring any kind of value, there's going to be this trustless layer that will be more fair, more accessible, and lower the barriers and lower the costs for making a lot of these transactions.
Right. And I completely agree with your thesis there. And honestly, didn't know anything about that MIT example. Would definitely love to check that out in detail a little bit more. But like you said, I mean, everything is likely going to be moving to blockchain. A lot of things will. And when that happens, companies like you and what you guys do, the infrastructure layer, you have to I mean, you guys are the ones who'll have to take charge of basically handling all that volume and all that requirement. So the infrastructure layer definitely has a big role to play in all of this development, and I do see that it's coming, it's happening very soon.
Yes, yes. People say that blockchain is the future, but it's already here. But it's just it's an experimental state. It's still a lot of
Yeah.
experiments, and a lot of things. There's mistakes being made, and yes, some value is being lost or completely eradicated. But this is progress. You need to have this
Right.
to eventually have these nice polished applications that are widely adopted. And so yeah, the infrastructure layer, that's what we're super passionate about. That's what we've been doing for the last 20 years, and we want to continue contributing to the evolution of the internet, and we see Quicknode being an avenue for us to do that.
Awesome. So thanks, Dmitry, for that insightful chat. I mean, I personally learned a lot. I had a lot of questions about understanding Quicknode and being able to differentiate it from some of the other tech that's out there. And I think what you just explained was super helpful, and I hope it is to the audience as well. So Yeah, I mean, thanks for joining us today on this podcast and being super insightful about everything that you do. And best of luck to you and Quicknode.
Thank you. It was a pleasure. It was a pleasure to be able to discuss these topics, and I hope that this reaches the proper audience and helps them understand just a little bit of the evolution or the revolution that's going on, and what we'll see in the near, on a much more broader scale, mainstream scale, in the very near future. Thank you, guys. Appreciate it.